All right, so we have our polar region, very cold in these areas. We have our tropics, it's very hot or torrid there. And I want to make sure I'm not writing in that giant of a font because that would be pretty bad. This middle part is called the temperate region. The temperate region. Okay? Temperate region. Now, I'm going to show you something that when I do it the first time around David, you're going to be like, Mr. Bones, that makes complete sense. And then when I do it the other side, you're going to be like, okay, this is a little confusing. But I think if you think about it in one way, you'll be fine. All right? All of these things are falling on these lines. And what were these lines called again? The lines of latitude, right? These same regions, thank you, ma'am, that are broken down are also broken down into the latitudes. So they're going to call this top latitude area the high latitudes. That makes sense, right? It's at the very top. Guess what they call the one in the middle? These are called the mid-latitudes. And down here they call this the low latitudes. Here's where it does get a little weird looking though, Nicola. It goes from low, and what do we call this area here? Mid. And then they're going to call this one at the bottom the high latitudes again, which is a little confusing, right? But high, mid, low, high, mid, low. That's not very hard. If you remember the mid-latitudes, that's probably the most important thing that we're really going to cover. Sound good? Because why is the mid-latitudes important? We live there. Why is the temperate region important? We live there. Why do you need to know about the tropics and the equator being the warmest? Because the sun is the most intense there and it stays warm all year round. Because that influences weather around the entire globe. Make sense? For my people at home. So we just spent, over 15 minutes, because I even had to bleed into a second video for this, right? Of latitude and longitudes, and we spent most of our time talking about the different areas of latitude if you look at our notes. We have the high latitudes, the mid latitudes, the low latitudes. It's cold, it's cold. It's temperate, meaning that it goes through seasonal changes like we do here, and it's pretty hot. Make sense? That part's pretty easy, and we're going to get into some stuff that's a little bit more difficult here in just a few moments. If you're watching it at home, you're going to have to watch this video because I can't play this and then upload it to YouTube. That leads us into something else, because now that we've talked about all of the different latitudes and longitudes, and we've learned how some areas are generally warmer than others and some areas are colder than others, we need to talk a little bit about air temperature. Now, this picture over here should seem very familiar to you. What's going on, without me explaining it, what's going on in this picture right here? Nicola.
The hot air molecules are hotter particles are hotter.
That's right. Now, you got to understand that these are both visual representations of air. The warmer it is, the warmer the air is, the more energy the molecules have and the further spaced apart they are, which leads me to this. Cold air is more dense. It's heavier. Why? Because the molecules are closer together. This is important because what have we learned about cold air? Cold air sinks. Now, all year we've said hot air rises, cold air sinks. Okay? Right? Now we need to know why cold air sinks. So what I'm going to say about that is this, as I see more and more notes that I've taken. Write this in blue. Not in that. What am I writing in? Like Sharpie? Goodness gracious. There we go. So if I were to put the cold air in a box, now these molecules are far enough apart that they're not bumping into each other, right? These molecules are not bumping into each other, but they are a lot closer together. Cold air has less heat energy. Molecules are closer together. Why is that important? Cold air is more dense, and that is why cold air sinks. I know some of you are looking at Mr. Bullets. I've already written this down. This is hugely important that you understand that cold air sinks. Now, if it is important for us to understand what the molecules look like in cold air and how that affects what cold air does, it is equally important for us to understand what the molecules look like in hot air and therefore understanding what hot air does. Because hot air has more heat energy. The molecules are moving further. They're spread out more. Therefore, hot air is less dense. And that is why hot air rises. Why hot air rises. So I will jot that down. It's pretty much going to be the exact opposite of what this looks like. And I'll even do it in red. Molecules have heat energy and air farther apart. This makes hot air less dense. And because of that, hot air rises. And due to that, hot air rises. If you look at your vocabulary sheet for this week, you'll see updraft and downdraft. Does that have to do with air temperature? Yes, absolutely. Convection cell, air temperature. Okay? Sea breeze, land breeze, mountain breeze, valley breeze, all have to do with air temperature and heat rising and cold sinking. This is huge. I know you're thinking I've heard this before, but we've never gotten this detailed with it. Humidity. I'm not going to spend a lot of time on humidity right now. This is the old term we've already covered, right? What measures humidity, Cruz? The hygrometer, and it's how much water vapor is in the atmosphere at a given time, right? Skip over that for now because it's important, but when we need to come back to it, we will. Updraft and downdraft. Updraft and downdraft. Now, these, Lila, I'm not going to stop and write things down. Number one, you have the definition on your vocabulary sheet. Number two, it's on the board here. And honestly and truthfully, it's exactly what it sounds like. When you have an updraft, that is hot air rising. That's pretty easy, right? What is an updraft? Well, it's an upward movement of air. What kind of air moves upward? Hot air. Pretty simple, right? When you have a downdraft, it is exactly what you're thinking. It is a downward movement of air. And what kind of air moves down? Cold air sinks. Cold air moves down. Now, this cycle of updraft and downdraft, where I have hot air going up and cold air coming down, Maya, hot air going up, cold air coming down, hot air coming up, cold air coming down, I have this thing called a convection cell that it forms. And that's going to be something that we really need to pay close attention to. So if you're at home taking notes on this, I'll probably write it on the anchor chart for the class eventually, but I'm literally going to write this. And here's a great view of what updraft is. Upward movement of warm air. What's this? Downward movement of cool air. Now you'll notice, look at this. When you have a downdraft, what kind of pressure do you have? High pressure. When you have an upward movement of hot air, what do you have? Low pressure. Kids, that makes sense. There's a bunch of hot air rising into the air. There's probably going to be some moisture in it. And you're going to have a rise in the availability of a storm to happen, right? If cold air is pushing down on you, it's going to be clear, cool, and sunny. High pressure. Everything should say, oh, wow, Mr. Boy, that starts to make a lot of sense now. Wind. Wind is a horizontal movement of air. Air moves from high pressure areas to low pressure areas. You need to take the time to write that down, not the IND, this part. Stop highlighting that. Air moves from high pressure to low pressure. And that is how wind happens. It's not moving from low pressure to high pressure. It's moving from the high pressure to the low pressure. Now that we've written down how air moves from high pressure to low pressure, we need to understand something. Is the earth heated evenly? No, we just learned a few minutes ago that some places don't get a lot of sun and they're very cold. Some places get way too much sun and it's super hot all year long, and some people are in the middle, in the temperate regions. Because of that unequal heating of the Earth's surface, do you see this? Air pressure differences come from the unequal heating of the Earth's surface. You want to jot that down. Why are there even high pressures and low pressures in wind to begin with? Because of the unequal heating of the Earth's surface. Why do we have air pressure differences to begin with? How do I have a place that's high? How do I have a place that's low? It all starts with the unequal heating of the Earth's surface. If we didn't have unequal heating of the Earth's surface, for instance, if we were flat, right? If we were flat, the Earth would be heated evenly, wouldn't it? Think about it. Flat. The sun would hit everything the same. No weather. Like, we can't be flat. I mean, you really need to understand that air pressure comes from the unequal heating of the Earth's surface. And wind is simply air moving from a high pressure to a low pressure. I'm going to leave that for my folks at home. That'll be my second video. We'll stop.